So the important thing is to remember, if we go back to here, remember I said that every character was actually a numeric value. So uppercase A was actually 65, and then it goes down to these bits and bytes. I said that last week. Lowercase a is a 97. So because letters or characters are essentially numeric, actually everything's numeric, but because they're numeric, you can actually treat them as numbers, which means you can do math on them. So, for example, and this is Unicode. It's using the Unicode value for 4 is \U0041 means Unicode. Well, if we were to look up the character value for 4, it would be 41. Under both ASCII and Unicode, by the way. And this would give us some value. That shouldn't be A. I hope that's not A. That should be. Well, this will be interesting to see if this is how this works out. Yeah, I don't think that should be A, but. Let's see what they come out as. I hope they don't come out as A and 4. That quite frankly doesn't make sense, but it does come out as A and 4. Unicode 41. Interesting. Okay. The point is, though, because it's numeric, I can add a plus plus to each, and you'll see that instead of A and 4, we should get B and 5. Right, B and 5. And the reason being is that it's numeric. So it increases 1 to this letter and now becomes B instead of A. Would payment... No. Oh, payment equals payment minus. Maybe. Would that work? That's a good question. Let's see that. Maybe. Let's give it a try. So you're saying return and payment, or we say amount, minus amount %.01. Might work. It's a lot simpler, that's for sure. Yeah, very good. Who was that? Very good. It's a simpler way of doing it. Yes, it would work, apparently. It makes sense. It's definitely easier than all that casting. Alright, good. Extra credit for you. So you can always do math on a single character, because ultimately, a character is what we call an unsigned int, which we'll get to later, but it's basically an integer. You can also use these Unicode characters to put Greek letters in, for example. And I know last week we did put something in. Get this message box thing. What do we got here? So let's create another one, another new class, and I'm going to make this easy. Actually, we had this in our one last week, if I remember correctly. All right. It's the option pane. Show message dialog. Okay. So back to this here. I think we can do this pretty easily just by saying alert and see if this works. Yeah, there we go. We got our Greek letters right there. So by putting the actual number, and you can also do the same thing with Chinese as well. So what you need to do is find out what's the Unicode value for those characters, and you can display them. There are special escape characters, what we call escape characters. And if you look at here, what you've got, the \U is, when you put the backslash before a letter, it usually gives that letter a special meaning. So \U means that you're going to use a Unicode value. And in this particular case, it's 03B1. So now I know why 41 was A. They're using hexadecimal, which is base 16, instead of decimal. If you don't know what hexadecimal is, Don't worry about it. We'll get to it, but it's a different numbering scheme. It's not digital. That's why it was. And I had a feeling that's what happened. So I guess on the Unicode they're using hexadecimal. So 03B1. These could translate to a decimal value, and 41, a hexadecimal probably translates to 65 in digital, rather in decimal. In any event, you can produce any character you want simply by finding the Unicode value. And every button on your keyboard has a Unicode value. So the backspace is Unicode 0008. And it can be represented by the \B. Tab would be a tab. And so, for example, when I run this, I get that. Now, if I put a \T after each one of them, it should space them out further because it's going to put tabs. Well, it didn't. Normally you would get some tabs. It might be that if I put 2 tabs, we'll see it. Let's just try with this one. Still not. Strange. I thought it would have. But you'll use some of these a lot. You'll use the \T, \N, and \R. So this should actually do it. So if I put a \N, which means a new line, this should put each one of them on their own separate line. Yeah. The \N put each one of them on their own line. And a double backslash is sometimes you just want to print a backslash. But if the backslash has a special meaning, how do you print just a backslash? Well, you double them up. \backslash takes away the special meaning of the backslash. So, and then also the single quote generally means a single character, but what if you want to put a single quote inside of your single character? So then you have to use a backslash. So, for example, if I were to create something and just put, let's say I want to put a backslash between each one of these. And let's just take this here. I do a backslash. Now I get an error because it says illegal escape character. But if I double it up, now I've got a backslash. Now if I do this again and we run it, now you'll see a backslash between each one. Right? Single backslash. Same thing with a double quote. I might want to put a double quote around each one. But if I do that, the problem is, because the double quote denotes strings, since I put that double quote there, it says, okay, the string's ended and all this stuff is outside the string. And that's a problem. But you can escape the special meaning of a double quote with a backslash. So, yeah, I know that gets a little confusing. Well, you're not likely to hit anything like that anytime soon. But those are your escape sequences for different characters. Here's an ASCII chart which shows you all the different values. So if you want to know, like, for example, 65, you come down to where 5 and 6 intersect and you get A. So ASCII charts are useful to have. We used to, in the early days, we needed ASCII charts all the time because we needed to know what the numbers are. Today, though, the IDE like NetBeans will tell you, so you don't really need to worry about that. And these are the \. Unicode values. We would see that 41 is A, but it's because it's in hexadecimal. That's a hexadecimal. Whereas the ASCII chart is in decimal.